Okay, we're going to put all of this stuff together to actually solve the problem we wanted to solve in the very beginning. Find all the roots of the polynomial 2x to the fourth minus 5x cubed plus 20x squared minus 45x plus 18. Now, one thing that I'm going to include on the Google Classroom, if you're seeing this in Google Classroom, or if you're in class, is I'm going to include a step by step. So let me go through the step by step. I'll talk about where all these steps come from, and then we'll go back and we'll use it on the problem. The when we actually use it will probably be the next video, but this is kind of like the warm up of why we just went through all of that stuff. Well, the first step to any problem would be to write it on your page. So that one's just kind of that's what's happening. You got to write it on your page. If you don't write it on your page, you're already putting yourself at a disadvantage. The fundamental theorem of algebra and its corollary tells us how many roots of the of that polynomial we're expecting to have. You have to know how many you're going to start with, right? Next up, you're going to determine all the possible rational roots. That is the rational zero theorem, right? We're going to take the constant term and all of its factors and divide it by the leading coefficient and all of its factors, and it's going to tell me all the possible rational roots. I've just narrowed my list down from an infinite number of choices that could be roots to a much smaller list. Even if it's like 32 numbers, so way smaller than infinity. We're going to try to reduce that list again and give us some clues about what I should expect when I'm trying to solve this function by using Descartes' rule of signs. And we're going to figure out how many positive, negative, and complex roots there are. This tells me things. If I find that there's going to be one negative root, I'm going to start looking through all the negatives of my rational roots. I might find it because it might not be a rational number, but that tells me something. If I go through all my negative rational roots and I don't find the one negative I'm expecting to find, well, that means it's going to be a irrational root, which means I should start definitely looking through those positives, and I'm expecting to have a quadratic at the end that I have to use a quadratic formula on. Okay, when you finally, this is like all the first four steps are all your planning routine. Okay, that's you're just trying to organize your thoughts about it, get everything going. Step five is where you actually start solving. You're going to use synthetic substitution because it's quickly a quick way, combined with the factor theorem, to find factors of polynomials. So you're just going to be looking at your possible rational roots and plugging them into synthetic substitution over and over and over again. Just boom, 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 trying to get through them as quickly as you can. Because whenever you find a root, remember that's when the remainder is zero, you start using the depressed polynomial. You don't go back to the original. You've already done a work to factor out a whole thing. Like if I'm trying to factor out a cubic, and I just got it down to a quadratic, I'm not going to just go back to the cubic to keep looking through roots. I'm just going to start working with the quadratic. So um, you're going to use the depressed polynomial. And you can do that in combination with the Descartes rule of sign to decide whether or not you need to keep checking them. If I'm looking for one negative and I find it, I'm not going to look through any more negatives. I found them already. So I'm going to switch over to the positives and start looking through those ones to see what I can find. Um, the last bit is, let's say you start on a fifth degree polynomial and you find three roots through synthetic substitution. Boom, boom, boom. And you've depressed the polynomial all the way down to a quadratic. Stop using synthetic substitution. You know how to factor quadratics, or at the very least, how to use the quadratic formula to solve them. So once you get down to a depressed polynomial that's factorable, for me that usually means a quadratic. So there would be like number, 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 and then the zero for the remainder. Uh, or if I happen to notice it's going to be like a sum of two cubes or something like that, then I would stop there too. That one's a little bit harder to spot. I'm going to stop there and I'm just going to start solving it like I would a normal quadratic because I've already found all the other answers. I'm just looking for the last two. And the last bit is check to make sure that the number and type of solutions you have match what Descartes' rule of signs says, and that you have the right number from the fundamental theorem of algebra's corollary. If you get to the end of a fifth degree polynomial and you've got four answers written down, you're missing one. So you better figure out what happened. Chances are you probably, on some square root somewhere, you forgot to put plus or minus on it. But you never know. You got to double check your work. All right? So those are the 6 steps. Step 5, we kind of repeat a bunch. The first 4 steps are the planning, and step 6 is just double checking to make sure it makes sense. All right, so we're going to use this process to find all the solutions to that polynomial.